Hello and welcome to this tutorial on how to connect to a Postgres database in Rust to create and then retrieve a row, storing it into a Rust structure. Alright, I already created my project and added a couple of dependencies and invoked cargo build so we could retrieve this code and cache it for later. All right, so let's get some context about what we're going to do in this tutorial. So here there's a bit of documentation on what dependencies we're going to use. Here you can see we're using Chrono to deal with timestamps and timestamps with time zones. And here we're dealing with Postgres to manage the database connection and the execution of SQL code from Rust. So go ahead and check this and this so you can get more information about what we're doing. Now let's have a quick overview of all the things we're gonna develop today. All right, so here you can see the cargo commands I invoked to create this project. As usual, cargo new database example, then we change directory into this database example project. We built the project so we could cache these dependencies in the cargo.toml file, and then later on we're going to invoke cargo run to execute the code inside this main.rs file. So let's see what we're going to do. So we're going to connect to the database, we're going to create a new row, we're going to retrieve that row we just created and create a Rust structure based on the information we retrieved from the database, and eventually we're gonna disconnect from the database. All right, so in order to be able to connect to this database, we need to have a database instance running, and we need to create some tables into this database so we're able to run the Rust code without errors. Let's go ahead and check this makefile to see how we could configure a database, and then also this SQL file containing the schema to create this table. So if you're not familiar with makefiles, they're not that difficult. Basically, they are made of what they call targets, which are very similar to the idea of a function. And you could set dependencies between targets by specifying them in the list after this semicolon. What we're going to do is invoke make blank space create -db, which is a target depending on nuke database. So make as a command knows that it first needs to execute nuke database and then invoke the create database target. Now, as you can see here, these targets are basically wrappers for the pSQL command, which is a command line utility to interact with the PostgreSQL. And here you can see that we are dropping the database if it's there. Then we are creating the database, invoking this alter database to be able to show logs from the database service to see basically the SQL queries we are performing. And we are invoking this schema.sql from our code base to basically drop the table works if it's there, and then create the table works. So this is basically a dummy table that is pretending to mime some sort of business logic. Let's pretend we have a work code, and let's pretend we are supposed to add together numbers up to a threshold. And let's pretend that we want to know if we are done or not in doing this very expensive task of adding together numbers. Also, we want to know when we created this row, and I left this here for reference, but if you want, also you can maybe update the row when you're done, depending on the fact that it may take more or less time to perform this work. One last thing, here you see variables, and the variables are defined here. So this is the password for the Postgres server, this is the host, so it's localhost, and this is the name of the database we're gonna create. In order to run a Postgres SQL server, there are various ways you could do this. You could use Docker with these commands. In fact, that's how I'm doing it. As you can see here, we create a volume, and then we invoke docker run to create a container based on this Docker image, which is from the Docker Hub and is the official image for Postgres. Here you see we are mapping the volume, so we store all the data in this Docker container into our file system via the Docker volume. Here you see we set the the Postgres password, the one we defined in this variable in the make file, and we're mapping ports, and we're giving a name to this Docker container. If you're in Debian Ubuntu, you could invoke this command. I'm sure you're pretty familiar with these kind of things, and so you can set up your Postgres server, Postgres database. On Mac, I'm pretty sure you could do something very similar with Homebrew. On Windows, you could do this in a variety of ways. One of them could be by using the Chocolate package manager, something very similar to the idea of apt or Homebrew. All right, so let's go ahead and invoke make create database, which is gonna drop the database if it's there, then it's gonna create the database again, configure a bit this database, and then eventually run this SQL code inside the schema.sql that is gonna drop a table if it's there, and then create the table again. Okay, so as you can see, we need to go into the DB subdirectory, and then we're gonna basically invoke make create DB. Okay, let's quickly have an overview of what we did. We dropped the database if it was there, created the database, configured the PostgreSQL server instance, and then invoked this schema.sql file and executed those SQL statements so then we were able to create this table in our Postgres database. All right, so let's go ahead and move on into our Rust programming. So let's import some modules that we're gonna use while programming in Rust. Here you can see we are importing the Postgres modules, client, and no TLS from the Postgres dependency, and here datetime and UTC from Chrono. And these are dependencies defined in our cargo.toml file. All right, so let's go ahead and write some code about connecting to a database. And here you can see that we are invoking the connect function coming from the client structure that we imported from the Postgres module. And we're providing a connection string that, and I guess you can recognize the password we used for the database, the fact that the host is localhost, and the name of the database. And here you can see these are the same variables we used to configure our database. Once we have a database instance, one moment, I need to check. Okay, once we have a database instance, later on we're gonna create a row, we're gonna retrieve the row, but eventually we're gonna disconnect from the database. And given this database instance, we're gonna invoke the close method that needs to be applied to the database client, that, as usual in Rust, is gonna return a result that could be either an OK or an error. And we want to invoke the assert macro to make sure that this result is okay. Otherwise, the macro is gonna fail and we're gonna panic. All right, so let's go ahead and run this to see if it works. Okay, so we didn't panic, so we can assume that we were able to successfully connect to this instance of a Postgres database, and we were also able to close this connection without any error. All right, so let's move on and create a row in this table. Okay, so here you can see that we are, so let's put this schema on the side so we are able to compare. So these are the details of the table we created, the dummy table related to works. So we pretend we are adding numbers together up to a given threshold. So we generate a full code, work code, and then we want to add together numbers up to 42. Okay, so we're gonna use the query method applied to the DB client to run some SQL. And the SQL is insert into the works table these values. And we are injecting the values with this syntax, and we are providing the values here to the query method. One thing to notice is that in Postgres, we could return the ID value for the row we just inserted. So basically, Postgres comes here to this table, it inserts a new row, and then given that this ID column is managed by Postgres itself, it just returns back the value for that column, the identity column. So we know how to identify this row inside this table. All right, so if there is any error when running this query, then we're gonna panic and say cannot create a row. But assuming there are no errors and the query has been successful, we're gonna store these rows into a vector of type Postgres row. And this Postgres row is something we can process later. Now we know we have inserted only one row, so we can perform some checks on this vector, basically the size of this vector. So if either this vector is empty or has a length greater than 1, that means there's an error. So we're gonna panic and say number of rows not expected. So at this point, we know that we have some data and we can process that. So we set an ID row of type option with the generics I32 because this ID column is a serial number. And then we're gonna invoke the get method that can be applied to a row, a Postgres row. This code comes from our Postgres dependency. And that means we are storing the option inside the ID row variable of type option generic I32. And then we're gonna print this message with the print line macro. So we're gonna show the work code, the work adapt2 variable, and then we're gonna unwrap this option to retrieve the actual value of the ID column, and we're gonna print that as well. All right. Now, assuming we flushed this row into the database, then we need to retrieve it. But in order to retrieve this row, we need to define a Rust structure that represents a row from this database. So we're going to define this structure. All right, so in here, you can see that this Rust structure is very similar in principles to this definition of the table. So we have an ID field, a work code of type string, an adapt2 field of type I32, a boolean called done, and then we have created on of type datetime UTC. So these types come from the chrono library we imported. You see here we imported the chrono module and we defined the chrono dependency in our cargo.toml file. Okay, so we're gonna retrieve this row from the database and we're gonna store the information coming from the database into a structure of type work. All right, so let's get this code into the code base. Let's move this back here so we have more space to read the code. Okay, so we know the table was new, so we can infer that, well, we can assume that the ID is going to be ID equals to 1, but in case we don't want to do this, we could use this ID row unwrap to retrieve. Maybe, we store the ID directly in a variable of type I32, we unwrap the option, and then we could use this ID in here. Okay, so again, this is the query method applied to the DB client coming from our dependency called Postgres. And we are selecting all the columns from the table works where the ID is this placeholder, and this placeholder comes from this parameter, and this parameter is pointing with a reference to our variable that we define here. Given that the query method returns as usual for Rust a result that could be either a vector with a generic type row from the Postgres dependency or an error, we want to make sure that there are no errors, and in case there's an error, we panic saying cannot retrieve rows. So now that we know that we have no errors, then we unwrap the rows and we store them in a vector with a generic type Postgres row. Now, this ID equals 1 means that we are identifying exactly one row with that specific ID. So we know that this vector is going to contain only one element. So if the length of this vector is 0 or greater than 1, there's something odd. So we panic saying number of rows not expected. Otherwise, we're gonna loop on this vector, and for each element of this vector, we're gonna instantiate an instance of a structure of type work, the structure we defined at the top of this file. And we're gonna take all the information coming from the row of type row from Postgres, the Postgres dependency, and we're gonna get the ID, the work code, the add up to, the done field, and the created on field. One thing to notice is that we are using the chrono datetime type, and in here in our toml file we specified in the Postgres dependency that we are using chrono as a feature. So these two dependencies could work together in order to be able to store the datetime information into this field for this structure. Okay, so let's run this code and see if we are able to create a database connection, create a new row, and eventually retrieve that same row and close our database connection. So cargo run. And there you go. We are creating a new row, and for work code, full code, and work adapt to 42, the ID that we retrieved is 1. Let's quickly recap. We perform this SQL command, and we were able to retrieve the information about the ID, and so we were able to print that in our with the print line macro. And then we have retrieved that row via this SQL statement, injecting the ID equals to 1. And eventually we were able to create a work structure, and we were able to print this information with the print line macro, with all these fields coming from the database retrieval that we did here. And as you can see from the output, in the standard output, the ID equals to, well, let's compare with this code, right? So the ID equals to 1, work code, full code, the one we inserted, add up to 42, the number we inserted, done is false because the default value in SQL for this field is false, and created on is the timestamp. All right, that's it for today. Happy Rust coding to everyone, and I will catch you on the next one.